Hello everyone, we are proceeding with our foundation work, and this is all about, this tutorial is all about slab steel bar or slab reinforcement bar, which you can also use the template or the customized template for raft slab and suspended slab. Let me show you the section of this. This is ground. According to this structural drawing, this is ground floor slab details, and this is the section. This is the section. This is the section. We have full mats at the top, both vertical and horizontal reinforcement bar at the top, and at the bottom you have full reinforcement bar with laps. As you can see, you have laps at the top of the raft beam. So let me show you the pictures. Some pictures. This is raft slab. This is the top. I don't know, maybe you can see it clearly. This is the top reinforcement bar, horizontal and vertical, and this is hose bar. The function of this hose bar is to raise the top bar up so that when casting or when workers are working and moving here and moving on the reinforcement bar, it won't press it down. It will maintain a stable position so that the top bar won't press down and it won't break the plumbing work or electrical work, so that it won't have any effects on the plumbing work or anything placed under the reinforcement bar. That is the function of this hose bar. So this is the we have top and bottom bar. I want to show you something. This is the bottom bar, the one under this reinforcement on top of the raft beam is the bottom bar, and this one that is on the beam is the top bar, and this is the laps. You have laps at both sides. Same thing applicable to this one. This is the bottom bar, is on the top of the concrete, and the top bar is on the top of the beam. Let me show you another picture. This is the reinforcement, and this I want to show you laps. You have two laps. At the both side. So you have reinforcement at the top. So according to this picture, we call this one top, and the one under it, we call it top bottom. Understand, top bottom. And this one under is on the concrete, we call it directly on the concrete, we call it bottom, that is BB. And the one on top of the bottom bar, we call it bottom top, that is BT. Yeah, we call it BT. Good. I haven't scaled this page. I haven't scaled it. Oh my god. So let me scale it. Let me scale it so that make our work fast. I'm very sorry because I haven't scaled it. Let me scale it fast. Let me confirm it. Okay, okay, yeah, it's correct. It's okay. So good. So let us start with the templates. Yeah. So let me first explain some things before we start customizing the templates. So firstly, in this tutorial, it's based on two aspects. The first one is um, counting, taking off with counting takeoff tools and using, I'm going to make use of counting, like uh, count method, takeoff tools, yes, and using linear method, count method and linear method, yeah. So good. Then first explain this. We have this is T. This T means top. It means top bar. Top bar. It runs like this. Anywhere you see this call out, this dimension, something like dimension from this point to this point, and you see these dots on the reinforcement bar, that means you have to trace this call out to this side or vertically, able to know that, able to determine the details of the drawing. So this is 18 numbers of Y12, bar mark 01, and the center to center is 200 mm. So now this reinforcement start from this point and end here, as in how it is being distributed, and the reinforcement bar runs from here to this side and bend like this, and bend like this. For okay, let me now want to sketch something. This is raft slab, right? So for raft slab, this is how the reinforcement is being placed. For raft slab, something like this. It turn upside down. It's turn upside down. That is how Raft Foundation slab is being positioned, is being placed, and now place it like this. Slabs, you understand? But for suspended slab, it's vice versa. Like as it is now, you turn it again upside down. I'm coming. Let's bring it like this. You get it? So this one is for raft slab, and this one is for suspended slab. So let me delete it. Yeah. So I've explained this one, right? So let me now explain this one. Let me check this one. Okay, good. For this reinforcement bar, it starts from here and terminates here on this beam. So check this call out. This dot that is on it, and this is how it is being distributed. Let us check it out. It starts from here, it stops here, and it continues from here. This is beam. This is beam. This is raft beam that runs from this point to this point. So this reinforcement, where am I? Okay, yeah, it continues from here. Anywhere you see anything, any space like this, that means there's a beam here, suspended and raft beam. So it continue, it continue, it continue. So it stopped here, it stopped here. You understand? It stopped here, and this line pro proceed. or extend forward in order to call it out to show the details of it. So we have 46 numbers of it of Y12, bar mark 11, and center to center 200 mm. See, that is top bar. So that is how it's being done. So let me explain this one. This one is supposed to be bottom. Yes, this is bottom bar. Yeah, this bottom bar, pick from this point, stop here, continue from this point, stop here, continue again, stop here, continue again, stop here. That is how it is being distributed. So let's get started. Let's go to our template. Let us continue with the previous one we've done. I have to explain it before we start customizing it, you understand? And I've done that. So just click on reinforcement folder. Then just start with can't take off tools. So let us name it as slab steel bar. Slab steel bar. Slab steel bar. Click on advanced. Click on advanced. Now it is time to add properties. Let's first add diameter. Diameter. Let's add diameter. So let us add this. Let us add the formula for the diameter, or the size of reinforcement that can come across on the drawing for slab, like 10 mm diameter, 12 mm, and 16 mm based on the drawing. Click OK, and you see now there will be a drop down for you to select anyone you like. So let us proceed. After diameter, you have bar weight. Bar weight. Bar weight. What is the bar weight of 10 mm? The bar weight of 10 mm is 0.617. Of 12 mm is 0.889. Of 16 mm is 1.579. Yeah, I got it. Sorry for the last tutorial that I mixed it up. So now, after bar weight, you proceed with center to center. Center to center to center. Center to center, you can make use of, based on the drawing detail, 150. Sorry, I make use of 200. I make use of 250. Yeah. After center to center, you create long side and short side. Long sides. Next, short side. After that, long bar laps and short bar laps. Long bar laps. Then short bar laps. After that, I'm going to create total short bar length and total short long bar length. Total long bar length. And just copy it. Let's not waste our time. Just paste it. Total and edit it to short bar length. Good. After that, you have short bar quantity and long bar quantity. There is long bar quantity, long bar quantity, short bar quantity. So after short bar quantity, so we are going to move. So you can move all the properties that we've created. You can move it upward. In order not to waste our time, so you can move it upward by yourself. You understand? So now on quantity, so what I'm going to do now is that just delete this takeoff, and before you customize this formula for the quantity, let us first customize the formula for some of this. So now let us start with total short bar length or log bar length. Total log bar length. So we have long side for total log bar length. So we're going to move long side plus long side plus long bar lapse, long bar lapse. Understand? Then for short bar length, that will be short side plus short bar length, short bar lapse. Yeah. So it remain long bar quantity and short bar quantity. Let me first extend this formula box. Yeah. For long bar quantity, that will be short bar. That for long bar quantity, that will be short side. That will be short side. You have to be patient here. That will be short side to determine the long bar quantity. That will be short side understand divided by center to center, close it in brackets, plus 1. Do you know the reason why we are adding 1 to it? Once we get total quantity, once we get the quantity by dividing the short side. For example, if we divide the short side is like 10 meter, short side, the dimension of short side is 10 meter, and divide it with your center to center, and it give you like 5 numbers. We now add this 1 to it, so that one will take care of off cut, or can also take care of. Let me show you on pictures. Maybe I have it. Okay, I will show you. I will show you on the drawing. On the drawing itself, there is one vertical reinforcement bar at the side of the slab that is being bent. You understand? That is being bent. You can also take care of it and off cut. That one that you're adding to it. You understand? You take care of it. And some little additional reinforcement bar that we need. So that is the function of this plus 1. After adding plus 1, that is, let me re-explain again. To determine the long bar quantity, our formula is short side divided by center to center plus 1. You now open a bracket again, you now close it a bracket again, another bracket. You understand me? Close the bracket again. Now multiply it with total long length. Multiply it with total long bar length. You understand? After multiplying the total long bar length, you can close it under brackets. Can close it under bracket by rounding it up. That's rounding up help you to add some quantity to it. You now round it up. You understand? So you round it up. So that is how to determine a total quantity of long bar. To determine with this formula help us to determine the long bar quantity. And secondly, is vice versa. Like for here we use short, for this one we use long. You understand? So to determine the short bar quantity now, that will be long side divided by center to center. Sorry. Divided by center to center. Close it with brackets plus 1. Close the bracket again. Multiply it in total short bar length. Can also round it up. Can also add it up to add to the quantity. Yeah, just come down to long bar laps and short bar laps. For this one, I will explain when you are taking off, or let me input it now. I will explain when you are taking off. So now, for reinforcement bar in slab, there's a place that which good. Let me explain here. Let me use this picture. Good. This is the labs. Can you see now we have labs at both sides. So it depends on your choice. Or when you check the drawing, we're able to determine the labs that you're going to use. You understand? So let us use like 450 at both sides. And the labs here we have labs at one side, like on the same row. Yes, on the same row, we have just one point that is we have the labs based on the length or width of the floor plan. So now for the labs, let us use 0.4, that is 450, multiply by 2, because the lab is at one point, not 2 points. You understand me? That's why you are using this by 2. Adibit is 2 places. That will be multiply by 2 again. You understand me? So let us maintain this by 2. I mean 1 point. Seems applicable to the short side. That will be 450 multiplied by 2. Let us check. Let us input the unit for diameter mm. Diameter is in mm out of bar weight kilogram. Center to center meter. Long side meter. Short side meter. Out of this is meter. meter, total length, meter, meter, yeah, long bar quantity, meter, that's the total numbers of what, total length, that's the total length, total quantity of both the long side and then the long bar and the short bar, understand, diameter. So to calculate for the quantity, general quantity now, that will be short. You can use start from the long bar quantity, just move it, long bar quantity plus short bar quantity. After that, close it with brackets. After closing the bracket, multiply it with point. With the, just come down here. This is what I'm going to add, point count, because we are using count takeoff tools. We are using count takeoff tools. Let us check it out here. It for point count. The reason why you are checking it is because sometimes if I move it up, it may not to delay. That is why I want to check this. But yeah, point count. Okay. After point count, I multiply the bar weight. You can still move the bar weight here. It's very easy for us. Close the bracket again. That's way that we multiply this point count with total quantity that we get here. We now multiply with the point count, then that's why you are closing it. Then multiply it the bar weight. Move it here. Oh, I haven't add multiplication sign. Yeah. Multiply the bar weight. Good. The unit is kg. Good. So we are good to go. So now let us like do we are sorry, like we always do. Let us uncheck all these things. Don't need it. Don't need all this field. Don't need it at all. So don't need it. Don't need it. Let's come to form. No. Let us check some of the properties that we need. Mean diameter, bar weight, center to center, long side, short side, the two laps. Yeah, we need it. That's what we need at the form layout. Yeah, that's what we need. Let's go into layout. Let us first show all the units. Let's show the unit. Let us move it. Oh no. Yeah, good. Click on OK. So we are done. We are done with. Let's click on form. You have diameter, bar weight, center to center, long side, short side, long bar laps, short bar laps. Yeah. Click on OK. Let us first use this to calculate. Understand? So it's to calculate first before moving to the second method. Reinforcement. So slab steel bar, right? Okay, let us dimension it first to determine the total length of it. Yeah, yeah. Let me move this and move this. Good. So now we first take care of this top bar first. Then after taking care of this first bar, this top bar, according to the section here, we discover that we have reinforcement bar at the top and the bottom, all through. I believe there's no any reinforcement here. We know how to work on that. Understand? But we have reinforcement bar at the top and the bottom. Good. So now just take care of the first. Okay, let me first explain something. So we have vertical reinforcement bar and horizontal. Let me explain what I mean by vertical. This is vertical reinforcement. So this is vertical reinforcement. Also have horizontal at the top and bottom. At the top and what? And the bottom. Let me delete it. Don't know this one. Good. So now for the top bar, these are the top bar. Actually, this is bar marker 1. For the top bar, this is top bar, right? So is here, it terminates here, and another one continue from this side again. Okay, wait. It start from here and it stop here, right? According to this call out, this something like dimension 9 from this point and stop here, right? And this is the projection to this side. So that is the top bar. Let me check this one. Let me check another one. Okay, good. Okay, this is the continuation. This is the continuation of this. Can you see this one stop here, right? It's terminate here. It stop here, right? Then this is the projection. This one also starts from here. Can you see? Start from here, stop here. Excluding this beam, start from here again, stop here until it reach this side. So now, what I'm trying to explain is that to determine the numbers of lap points. That is what I'm trying to let you guys know. So we have laps 1 here for the top and for the top reinforcement bar. Yeah. So you have lap here, you have lap here. That is 2 points. Good for the top bar. So what of for the top bar? You have 2 type of top. You have top and top bottom. So it's not specified. Maybe this one is top or top bottom, but it's top. So this one the top. Yeah. What else? Yeah, for the horizontal, this one is for the vertical top. Yeah, for the vertical top, you have 2 lapse points out of the horizontal. Let me check this one. Let me check this one out. Maybe top, but I'm not sure. Yeah, it's also top. Yeah, that shows that this is vertical top, this horizontal top. So for the horizontal top, we have 2. We also have 2 points. Yes, 2 points. Good. You have 2 points. Let me check this one. This one is also horizontal top. Yeah, 1. Let me check this one too. It's also top. So now here you have 1 point here. You understand? So to be on the safer side, you can make use of 2 points. You can make use of 2 points, or let me check. You can make use of 1 point, yes. Because, for example, this is 16 meter, right? Good. I'm from Nigeria. So I have to let you know. I have to let you guys know I'm from Nigeria. So the length, the normal length or standard length of reinforcement bar in Nigeria is 12 meter. You understand me? It's 12 meter. So now 12 meter is not 12 meter again. Everything has reduced. It's around 11.8. So now to determine the lapse now, at least 12 meter will start from here, we stop somewhere here. So for us to get the lapse here, maybe just as 1 point, to be at 1 point. You see, a situation whereby we didn't get as 1 point or 2 points, it will be minimal, not too much. So what I'm trying to say is that you can use 1 point as a lapse, and when you get to site, with the one we've added to the uh to the template that we create, that one side is also, we also cater, or we also responsible for some off cuts, here. You understand me? So let us use 1 point lap. You understand? So Adebint is 2 points. That's 0.45 times 2. That will be 0.45 times 2 times 2 again. The 2 means, yes, I want to explain the 2. The 2 means from here to here. 1 from here to here. That is 2 at 1 point. Adebint, I want to use 2 points. Okay, good. For this one now, for this vertical one, so there is 2 points. Understand? There is 2 points here. So I'm going to use, that will be 0.45 times 2. To be on the safer side, you understand? Let us make use of 2 points for the vertical and horizontal. Hope it is clear now. Sorry for taking your time for explanation. So now let's get started. Yeah. What is our vertical? The long side. This is 15.7, this is 16.8. So this is the long side. Let's start with this one. And both the vertical and horizontal reinforcement bar, center to center is 200 and bottom is 200 mm, and diameter for the top bar, just name it as top, sorry, just name it as T, that is top bar. Diameter is 12 mm, 12 mm, bar weight of 12 mm is 0.889, center to center is 2, okay, is 200. What's our long side? Long side is 16.845. Yeah. What of short side? 15.756. Yeah. So according to what I said, I should make use of 2 point lap. So you multiply with 2. Let me by 2. You understand me? Right. You are using 450. Let me check. Maybe you should use 450. Let me cancel it. No. So I want to confirm. Be loud. Can you see? It's more than 450. Almost 900. Almost 900. So you have to confirm by yourself, not just assume. Don't assume anything. So we have approximately 700 here. So now, what I'm going to do now is that let us use 800 in averagely 800 as our labs. Understand? Just use 800. Let me check this one too. This one is too short. We have approximately 600 here. So let us use, in short, let us use 800. Yeah. So it depends on your choice. Can use anyone you like. Understand? Depend on your choice. So let us rename it as node. This is slab steel bar T. That is for the top there. meter, 12 mm, bar weight 0.889, spacing 200, long side we have 16.845, short side we have 15.756. Yeah, we are using 800 as our labs. Okay, multiply by 2. I mean 2 points. This one will serve as two side, like at one point you have two side of labs and two side of labs. Yeah, then these two means 2 points. Let's copy it and paste it again. So we are using circle. Yeah, so now just click it 1. You understand? That will be 1. That will serve as the top. Serve as the top. So click on escape. So wait. There's something I didn't added to it when I'm customizing it. So just come down to take off. Yeah, just come down to take off. Just delete it and add quantity to it. Just bring the quantity that we've quantity here, and the unit is kg. Yeah, so now check the legend. Show the legend. So we have 2.8. We have 2,859 kg. I didn't come back to the template to add the quantity. This thing will show. It won't show. It show another thing entirely. So we've done with the top. So what of bottom? The bottom is also 12 mm. Good. And the spacing is 12 mm center to center. Good. Center to center. That's for the bottom. So let us check the bottom height here. The bottom here, vertical bottom. Yeah, start from here, stop here, same thing, go like that to this side. So now start from this point, including the one that bend from the top. You understand me? That bend the top, you add it to it from this side to this side. Okay, there'll be a lap between this and this one and this one. There'll be a lap because this one will proceed like it continue like this to this side. Let's check it out. Let's check it out. Yes. Okay, this one start from here. Yeah, this one also start from here and also start from here. Yeah, good. So for the bottom now, yeah, it continue. There's a reinforcement bar that start from here, terminate here, proceed from here, terminate here. Okay. It's another continuation. Start from here, stop here, start from here, stop here. This is bottom. If I should guess, here is bottom. Let me show you on section. This is how it goes. Can you see? Start from here, stop here, continue again, round again, continue again, stop here, stand, continue again, pick from this side, stop here. That is how it's being arranged. So now what I'm going to do now is that for the bottom, how many labs do you have? You have lab point 1, point 2, point 3, Yes, is 0.3. This and this is 0.3. This and this 0.4. This and this 0.5. This and this 0.6. Yeah, this and this 0.7. This and this 0.8. Good. For the vertical, out of horizontal. Let me check this one down. It is bottom. Yes, B. So can you see how it is being separate? All these are bottom bar, and bottom bar peak from here to this place. Same to applicable to this one. Can you see? This one just move from this and run here. So same to applicable to the vertical and horizontal. So our lab for the vertical is 8, right? Yes. Out of horizontal, lab to lab this one is this 1, this 2, 3, 4, 5. A 1, 2, 3, 4, 5, 6, 7, 8, 9. With this one and this, that is 10. That is 10, 10, 10. So for this horizontal, let me just check it out. Let me just dimension it and confirm something. Good. You don't have much. Let us use 300. Let us use 300. 300 at the lab. Let us use 300 at the lab. It's 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10. So it depends on your choice. I'm working according to the structural drawing. You understand me? May reduce yours. May reduce yours to 3, 4 because on sites sometimes some people doesn't follow, which is bad. But sometimes not even sometimes, I follow structural drawing. And what some contractor try to avoid is that when you are cutting, you understand me? It will lead to off cuts, like maybe 12 mm, 3 mm off cuts. It be useless on site. That is why some engineers on site and some contractors didn't do all these labs. The situation where we are going to see any lab is just that just pick this one from this, start this one from this point, just place it straight. Maybe there be a lab here, and then we just come from here and lab somewhere here, not to waste any reinforcement bar by cutting it. You understand? This one is still okay, but you did for the for the top bar at 2 points. You understand? For this one, 10 and 8, that's a wasting of reinforcement bar. And cutting it leads to a lot of off cuts. But according to this drawing, I make use of 10 at the short long side and 8 at the short side. Based on the drawing, it depends on your choice. You understand me? So now, yeah, you're making use of the same area. Yeah, click on it. So just add B to it. So the same thing, you're using 12 mm, 12 mm, 12 mm. This is bar width of 12 mm. This center to center, same thing applicable to the bottom. 200, the long side. We have 16.845. Out of short side, we have 15.756. Yeah. So now for the long bar labs, according to this one, you have 10, right? I've said it depending on your choice. You can make use of 2 points. So what are we using? I said 350, right? So let us use 300. It's just bottom, or let us use 350 according to our dimension it to confirm. Just 350. You can use 400 depending on your choice. So these two mean stand for 1 point. Lap at both sides for these two. This time means 10 points. Understand? That is 2 times 10, that is 20. So copy this, paste it here, and change this to 8 for the short side. So let us can change the color to blue. Okay, press escape. Change this. Yeah. So let us check the quantity. The mistake I made the other time. I'm very sorry. Can you see what I said? Because I didn't change it. So the issue comes from the template that we that I've done. So I have to adjust it now. Okay. You know what? Let me delete it so that will be on the server side. Thank God that I haven't changed it on the template, that you're able to see what I'm trying to explain now. That without adjusting the template, this is what we're going to get the point count. So let me delete it. Thank God that I haven't changed it on the template. So now let's come back to the template and adjust it right now. So come down to the takeoff data. Yeah. Just remove it and just add the quantity to it. By adding the quantity, shows that you are transferring the information. You are transferring the information from the quantity. From this quantity, you are transferring it to the takeoff, to what are taken off. You understand me? So now, let's come down to home. So let us start over again for the bottom bar. So you are good to go. You are okay with this one right now. So now, for the short, yeah, this one is the bottom. So diameter for this is 12 mm according to the structural drawing. Bar width of 12 mm is 0.89. Center to center 200. On the long side you have 16.845, right? Yeah. Short side we have 15.756. Yeah, we used to 350, right? That time 350, yeah, 350. Multiply by 10, that is 10 points for the long side here. For the short side, let us copy it, paste it here, and change the points to 8 for the short side. So the color, you can maintain this color, just click on it and press escape. Can you see? Can you see now? So the reason why the quantity of the bottom bar increase is because of this lapse. Had it been you use the same 2-point lapse, we achieve the same quantity as we got on the top bar. So the reason why this one increase is because of the lapse. You understand? Because of the lapse. Because of the lapse. That's the difference. So now, so we are done with the first method on how to calculate for slab steel bar. Secondly, is by linear method. So let's proceed. Let's come down to templates, click on linear. Let us cancel it. Just copy this one. Not to waste your time, copy it, click on linear, just paste it. The same name, click on advanced. So we don't need budge property, just need there as diameter 10 mm, 12 mm, 16 mm is okay. Just check, just do it once. No wasting of time. No wasting of time now. Yeah. So after diameter, bar width, yeah, it's bar width of 10 mm. That is 0.617 approximately. 8 mm 0.889, yeah. 16 mm 579 approximately. Yeah, good. What is the units? kg. Yeah. After bar weight, we have numbers of bar according to what I said at the first method. So this we are going to make use of it. Numbers of bar. Numbers of bar. Numbers of, let's use T bar. Yeah. Numbers of T bar. Number. That is B number. Yeah. So now let's come down to form. Let's show the units. Yeah. So can bring it bottom of this. I mean the same row. Click on OK. Let us activate the quantity. For firstly the units in kg. So now to activate the quantity, that will be linear total because you are using. Let me just check it out here. Not to waste our time. Linear total, because sometimes we are dragging it. Very difficult. Linear total. Yeah. Linear total. Click on OK. Linear total multiply with numbers of bar. Sorry. Multiply with numbers of bar. Multiply. Just round it up. Yeah. Multiply with bar weight. You can also move this one. You can move all this. Move it up. Not to waste our time. That is why I don't even move it. You can move these three up. Be on it on same side. So now click confirm. We are done with this one. It's not too okay. Doesn't take much of our time. Yes, I want to make another. I want to repeat the same mistake. So I won't. No, 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 no. So now let's come down to take off. Yeah. Yeah, just remove it and input the quantity. Yeah. I think I make a mistake again. I won't make any mistake. So now good. So click confirm. Yeah, good to go now. Let me check it. Diameter, bar width, numbers. Yeah. Okay. Let's come down to home. Yeah, this one I won't take about all reinforcement bar because it will take a lot of time. But the first one, the fastest way, you understand me? But this one will take a lot of time. But if you wish to make use of this one to be more better, you understand me? So now let's get started. For bar mark, easy. You can start taking off from the bar mark number, starting from 1, 2, 3, 4, blah 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 like that. So now this bar mark, this reinforcement bar, start from here to here to here, and the length pick from here and stop here. So now let's get started. Click on this. What is the bar mark? That is Y12. Don't need to add any bar mark, just fix the size of the reinforcement bar as Y12. You understand me? Y12. So I have to adjust the first one we did. I didn't add the diameter of the reinforcement bar. It's very important. I have to add it. So numbers, good. How many numbers do you have here? You have 18 numbers. 18 numbers. Yeah, good to go. Click OK. Make sure that this record mode is at point to point. Just pick it. Click on this. Click on A. Make sure that it is not on auto. Click on F8 so to check it. Let's click the opposite side. Okay, Alt Z. Oh, sorry. Click on A again. Yeah, click on F8, make it straight. Yeah, click on escape. What do you get? What do you get? What do you get? Let me check. For this one only, you have 80 kg. So now let me just adjust this one. Just add 2 dots Y12. Understand? That's all. I just want to add to it. That is Y12. This one I'll give to this one. Just add 2 dots Y12. So that means that you are working on Y12 for the first method that we did. So we are done with this one. Let me check another one that is more complex than this, as it take a lot of time. Like, okay, let me take this one out. So for this one, let me check. I'm calling. Okay, anyhow. So now let me just take this one. Let me take this horizontal one. This one. Okay, sorry, according to what I said you'll be working according to the bar mark. Okay, this is bar mark 02. Just check the bar mark 02. The color come like this. Okay, this is bar mark 02. The bar mark 02 is the top. Is the top bar. So you don't need to add maybe top or bottom. Just fix the reinforcement, the size or the diameter. You don't need anything top or bottom here. You understand? So if you like, I'll fix it. But for me, I don't need that one. I don't need it. So now bar mark 02. Bar mark 02. This is bar mark 02 now. So now is bar mark 02. Good. That is also white. It's also 12 mm diameter. What is the number? My God, I need to use 2. I didn't check it before I start working on it. I didn't check it. I'm not sure this is Bamako 2. Yes, it's Bamako 2. Yeah. Click on A. Click on A again. Yeah, I said this one is more stressful. Yes. Control. Click on F8 so that's A. F8. A. And Z. A. F. F8. So now, how many numbers of it? How many numbers of this one do you have? So I'm going to do, you have 64. So let us edit it. So 64 numbers of it. What is the quantity? That is 281.8 kg. So in order not to waste our time, let's just jump or move to this one. Yeah, this one is bar mark 13. No, yeah, this is 13. Yeah, we have 14 numbers of it. 14 numbers of it. 14 numbers of it. It's also 12 mm. putting numbers of it. Stop here. F8 A and A again. F8, make it straight. Escape. So let's just check the quantity. You have 100.5 kg. So now this is how to customize and take off for slab steel bar or reinforcement bar. If you have any question, you are free to ask me any question. If you don't understand something based on how I customize it, or anything that mix up when I'm explaining. So you are free to ask me or chat me up on my WhatsApp. You are free. Thanks for watching and thanks for taking just a little out of your time. Thanks.